This is the second video for Chapter 3, and we're going to be continuing our exploration of the periodic table. This video is going to cover sections 3.2 and 3.3 in your book, so tour of the periodic table and categorizing matter. To recap, in the periodic table the elements are arranged in rows according to their atomic number, which is the number of protons in each atom. Hydrogen is at the top left and has just one proton and an atomic number of 1. As we move from left to right, the atomic number increases along the rows. So in this section we're going to do a tour of the periodic table and learn a little bit more about the elements and how they are organized. We know that the rows are called periods and the columns are groups, or sometimes called families. Elements in the same family or group have similar properties. Now you'll see that in this depiction of the periodic table, hydrogen is actually shown in the center rather than in its usual position at the top left. And this is because it doesn't really belong in group 1. In fact, in older versions of the table, hydrogen was not put where we see it today. So we're just going to show it here in the center for now. In this slide, I'm going to introduce some of the groups by name. So let's start at the left-hand side, and these groups are indicated with the red box. This is a group of metals, and it contains some of them that you probably know by name. From the top, lithium, sodium, and potassium. This group of metals is known collectively as the alkali metals, and that's shown on the slide. They're very reactive metals, and they're only found in nature combined with other elements. In pure form, they're shiny, like all metals, and these metals react violently with air and water. So those are the alkali metals, group 1. The second group of elements, now shown in the blue box, have a similar name. These are the alkaline earth metals, so make sure you can distinguish those names. The alkali metals are the first group, the alkaline earth metals are the second group. These metals are also reactive, but they're not as crazy as the alkali metals in group 1. Here we have metals such as magnesium and calcium, which are two elements that are important for the health of our bones. So you're probably familiar with those names. The whole center portion of the table includes a number of elements known collectively as the transition metals. And these include metals that you're familiar with. And if you look in there amongst them, you'll find iron, that's Fe, you'll find copper, which is Cu, zinc is Zn, and these are metals that are used industrially, and they're also required in small amounts for human health. Also included in the transition metals are metals such as silver and gold, which you're familiar with from their use in jewelry and things like that. On the top row of the periodic table, we have some elements that are in different families, but are worthy of note because of the fact that these are elements that are very common in living organisms. And so these include things like carbon, nitrogen, and oxygen, and they're indicated in green on my slide. So these are not as a family, I'm just indicating the fact that these are some very important elements that we're going to see in living organisms. Moving further left, we do have another family, and these are the halogens. And these are non-metals, they're all non-metals, and they are very reactive. These include the gases, fluorine and chlorine, bromine, which is a liquid, and iodine, which is a solid. And like I say, these are all very reactive elements known as the halogens. The final group I want to point out are the very last group, and these are known as the noble gases. As the name suggests, they are all gases. And these include helium and neon that you might have heard of, and these gases are very unreactive. So they really do not like to react with other substances. And in fact, the name noble comes from the fact that they were very snobbish and they didn't want to interact with anybody else. As we delve deeper into chemistry, we're going to explore things such as why are the halogens so reactive? Why are the alkali metals so reactive? And on the flip side, why are things like the noble gases so unreactive? But we'll get to that at a later stage in this class. This brings us to section 3.3 in your book, categorizing matter. Now, matter can be categorized in a number of different ways. If we think about this, we often categorize things in different ways. I could be categorized as female, or as a Brit, or as a biochemist. And depending upon which category I'm in, I'm going to share that category with a different group of people. So we have to bear in mind that categorization methods can overlap. And it's the same when we're categorizing our matter. So far, we've classified matter according to the periodic table in those three big classes: the metals, the metalloids, and the nonmetals. A different form of categorization separates substances into those that are pure substances and those that are mixtures. A pure substance is matter that contains only one type of atom or element, or is a compound which is made up of more than one type of atom, but the atoms are always in the same proportions. This figure shows some examples. On the left-hand side we have gold, which is an element. So a sample of gold without significant contaminants would just contain atoms of gold, so it would be pure gold. The three items shown on the right are all compounds. A simple example of a compound is the salt we put on our food, which is made up of sodium and chlorine atoms in equal proportions. Sodium chloride. A second example of a compound is water, which is made up of hydrogen and oxygen, always 2 hydrogen atoms to every 1 oxygen atom. And on the far right we have sugar. This is more complex, containing the atoms of carbon, hydrogen, and oxygen, and those are in a ratio of 1 to 2 to 1. So 1 carbon for every 2 hydrogens and every 1 oxygen. So these would be examples of compounds. Each compound has a fixed ratio of the different atoms that are present. So let's talk about mixtures. A mixture is one or more pure substances combined together. On the previous slide, I introduced table salt and water, both as pure substances. But if we put a teaspoon of table salt into a cup of water, we have a mixture. We now have the sodium chloride, the salt, and we have the water. We'll see that mixtures can be solids, liquids, or gases, and there are different types of mixtures. We can have homogeneous mixtures that are uniform in appearance, and the example I have here is chocolate pudding. You cannot see the separate items in chocolate pudding. At least you can't if you make it correctly. If you make correctly chocolate pudding, it's all going to look smooth and it's going to be uniform in appearance. It's obviously a mixture of many different things, but it is homogeneous. It all looks the same. If you mix that teaspoon of salt in water, mix it sufficiently so that the salt dissolves in the water, it's all going to look the same. It is a homogeneous mixture. Other mixtures are not homogeneous, they're not uniform, and they are described as being heterogeneous. And they have boundaries that we can obviously see. an example here, and this is in a solid. Remember, mixtures can be solids, liquids, or gases. So here's an example in a solid, and this is a piece of granite. And this granite is made up of several different minerals, and you can see the different minerals when you look in that piece of rock. So this is a heterogeneous mixture. So in this section, we've just talked about pure substances that may be single elements or compounds, and we've also talked about mixtures, which are when we have one or more pure substances combined together. And our mixtures may be homogeneous, uniform, or they may be heterogeneous, where we can actually see the different substances that are in the mixtures. So this concludes the second video for Chapter 3, covering sections 3.2 and 3.3. To help with your review, I suggest you work through the study questions in this section that are in the book. You'll find the embedded study questions and the answers are after them, and that's a good way of seeing if you've got a good handle on this material. Okay, thanks.